Today, we will be introducing the second part of the query optimization, and this is the last lecture of this course. Actually, we will be introducing the concept of the join selectivity, which is the fraction of the matching tuples out of all the concatenated tuples that we can generate, and this is called the Cartesian space. We will be dealing with the first challenge, which is how to predict the number of the matching tuples in a join query. That is, how many tuples can be matched after joining two relations together, and this is called the join cardinality. And the second challenge is how to express the expected cost of all the strategies that we have been discussing as a function of the two fundamental components of the query optimization, the selection selectivity and the join selectivity. So we are trying to refine the expected cost as a function of two selectivity metrics, the selection and the join selectivity metrics. And then we will be discussing optimization plans over selection and join queries. And then we will be introducing the optimization in three-way join queries, where we're about to join more than two relations together. All right. In order to introduce the concept of the join selectivity, let's recall what does mean to associate two relations together. I'm having the relation employee with 5 tuples and the relation department, where we're having only 3 departments. And this SQL query here does not have the where clause. So we are dealing with the Cartesian products of these two tables. In that case, it means that we take one tuple from the employee relation and then we concatenate this tuple with all the tuples of the department relation. If we do that for all the employees, then we are getting this outcome. And of course, if we inspect this outcome, we will see some matching tuples. Actually, these are the real tuples that should be matched because they are having a real meaning. For instance, Chris is working in the first department because the foreign key department number attribute of the employee relation is referring to the primary key department number attribute of the department relation, but also due to the fact that we have not the where clause in our SQL query, we are also generating non-matching tuples. So we generate 15 concatenated tuples, and only some of them are the matching tuples. So we are creating a fraction out of the whole Cartesian space. We define Cartesian cardinality, the products of the cardinalities of the two relations. In that case, we are generating 15 concatenated tuples because the relation employee has 5 tuples and the relation department 3 tuples. Now let's introduce in our query the join condition, where I am associating the foreign key with the primary key. This means that I would like to retrieve only the matching tuples and not all the concatenated tuples. And of course, if you are doing that, this will be the reasonable outcome, where you're associating an employee with a corresponding department. Of course, we are getting 5 matching tuples, and then we are establishing the concept of the join cardinality. The join cardinality is the cardinality of this big associative relation based on the equality between the foreign key and the primary key. And then we are talking about 5 matching tuples. So join selectivity is the fraction of the join cardinality, where in this case is 5 matching tuples, out of all the possible concatenated tuples that we can generate. So In this particular example, the joint selectivity is 0.33, and actually it reflects the probability of selecting a matching tuple out of the Cartesian tuple space. This is the concept of the joint selectivity, if we're about to provide the metaphor of being a probability metric. Let's see another example. In this example, I'm searching for those employees being managers. So in that case, I am choosing the foreign key in this joint selection to correspond to the manager social security number attribute of the relation department, and the primary key to be the social security number, because I would like to retrieve only the managers of the departments. And since I'm having 3 departments, I'm expecting to get 3 managers, 3 matching tuples. And this is, and this is the outcome. The 3 managers, Chris, Phil, and Thalia, are the 3 managers corresponding to the 3 departments. So I'm having as a joint cardinality the cardinality of the associative relation, where in this case is 3 managers, and the joint selectivity is the joint cardinality out of the cardinality of the Cartesian space, where in that case is 15. So the joint selectivity is this fraction corresponding to the number 0.2, where this reflects the probability an employee being a manager, based on these instances that we're having of these 2 relations. So, when we are dealing with joint queries, then we have to determine which is this probability of finding the matching tuples. And in order to generate or better calculate this statistical probability, first we have to deal with the cardinality of the Cartesian space, and then we have to deal with the cardinality of the associative relation. So the definition of the joint selectivity now is, as we discussed, this fraction of the matching tuples between 2 relations, given that we are associating the foreign key and the primary key out of all the Cartesian cardinality. And of course, being a probability is a number bounded between 0 and 1. Now, just to let you know that the Cartesian cardinality is the product of the cardinality of the 2 relations, and then the joint cardinality is the joint selectivity times the Cartesian cardinality. So this is the definition. Assume that now we are observing a joint querying coming to our data management system, and we would like to predict the number of the matching tuples that should be retrieved in order to deliver this information back to the users or to any other applications. And we need to do that without executing the joint query, because as we had been discussing, all these joint query algorithms are computationally intensive. So in that case, can we predict the joint cardinality without executing the joint query? Yes, the answer is that we can do this, because this is a theorem that gives us immediately which should be the joint cardinality when we are associating the relation R and the relation S together using the joining attribute A and B respectively. Of course, the proof is beyond of the scope of this course. I have added the proof in the last slide if you would like to go through to see how this reasoning is going through in order to decide the joint selectivity and the joint cardinality. But as we can see from the theorem, the joint selectivity is a function of the number of the distinct values of the two joining attributes. So again here, the outcome of the tuples, of the number of the tuples that should be fetched, depends on the statistical properties of the two joining attributes. And in this case, we are focusing on the number of the distinct values of each matching attribute. And of course, this is the joint selectivity, and the joint cardinality is just the multiplication of the joint selectivity times the Cartesian cardinality, which is the product of the cardinalities of the two engaged relations. Let's see an example about how to apply this simple theorem in order to find the number of the matching tuples before executing a join query. Assume that we're having the relation employee and the relation dependent such that an employee can have 0 to many dependents. And then I am associating an employee with a corresponding dependent. I would like to associate these two relations together using the primary key attribute of the relation employee and the foreign key attribute of the relation dependent. And some statistics is that I'm having 2,000 distinct values of the matching attribute social security number of the relation employee. So it means that we're having 2,000 employees because we know that this attribute is a key attribute. And I am having 5 dependents, 5 tuples in the relation dependent, and then the number of the distinct values of this foreign key is 3. This implies that there are only 3 employees having dependents. And these are the 5 dependents of these 3 employees. When we apply this theorem, then we're just taking the maximum value of the 2 statistics. And then in that case, we calculate that the probability of the matching tuple is 0.05%. And if you would like to find the number of tuples retrieved before executing this join query, then we just need to multiply the join selectivity with the cardinality of the two relations. And in that case, we are expecting to get the 5 matching tuples as expected, because at the end of the day, these are the dependents of the 3 employees. And we are about to retrieve these 5 dependents. So this is the concept of the joint selectivity and the joint cardinality. What I would like you to know is just the joint selectivity is a function of the number of the distinct values of the matching attributes, and that's all.